uh, physical verification is nothing but uh, DRC, LVS, DFM checks. DRCs are nothing but there are some specified rules given by the fabrication unit. So, these rules is to uh, minimum spacing between the metals, minimum width of the metal. So we are how much we are width, we are height low. So we are like how much the width of the via and n diffusion n sub to n well, like n substrate is nothing but, so I will show you the substrate. So if you take it, if you know these things, so this is going to be my substrate. So this is going to be my annual. Here I am going to place source, like here also other annual will be there. So well to well distance, well to substrate distance, and how much will be the my uh, like whether if there is VDD, if it is VDD, so how much will be, this is ground. So this is going to be my channel, so in this if PMOS is here and NMOS will be here. So this is how it will be. So there are some specified rules. So these things we are going to discuss, uh, and other things are like in DFM we used to check whether antenna is nothing but whenever we had a large gate, a large metal wire connected to my gate of the MOSFET. So if my gate is large, so while fabricating there may be a chance of charge accumulation to my design. So what I need to do, so this charge accumulation will damage my gate of the MOSFET. So I what I need to do was, I will be breaking my net into a small pieces, like this will be my metal 1, metal 2, metal 1. So jumper, we used to say it as jumper. So jumper, we need to place these jumpers inside my design so that easy for them to fabricate. Obviously it will take more area, but we need to, my chip is not going to operate right if it is like this. So there is another idea. So I am going to place antenna diode in a reverse bias. So if I do like this, right, so whenever there is a huge charge accumulation happening, so the charge is going to be discharged through this path. This is going to be happening. And if there is any questions, we can discuss in the comment section. So I'll give you my mail ID also, you can ask. And physical verification we completed, and in detail we are going to discuss in the future videos. And the formal verification is nothing but in synthesis we used to get the golden net list. So after synthesis, the net list which we got, right, it is a golden net list. So uh, after verifying that, we will be getting the golden net list. So uh, the synthesized net list and synthesized net list. So LEC we used to say. Formal verification what we do in the front end. LEC is what we do in the back end. So what are the inputs of LVS? So LEC is like golden net list from the synthesis, and the post route net list. So why we used to take post route net list was, so since we got all the nets and all the things, all the logic will be same way as the golden net list what it is in the synthesis. Some cells are going to add, but logic wise it is going to same, no? So that is what we used to do. And and the LEC deck file, like deck file and guidelines deck file we used to say. And whether if you're going to give constants also, that will be also helpful. .sdc file is also needed. So .sdc file we discussed in the previous videos, right? Those are the constants that is needed for operating of the chip. And after doing LEC, we used to do the parasitic extraction. Why we need parasitic extraction? So uh, we had the uh, post route netlist, right? After routing, so what tool needed was R. The circuit should be RLC format. If it is L is depends upon the technology node, so RC format. And if it is a lower technology nodes, L is also needed. RLC format we need. So the parasitic extraction is going to convert my netlist from like it is going to be after we are doing the layout format, right? We used to get the metals, so each metal will have resistance, inductance and capacitance. So based on that, RLC design is going to design given by parasitic extraction tool. So parasitic extraction tool will be these values, some values it is going to give. So we are going to discuss it in future. So these values are given useful for determining the this is used for calculating the cell delays, or cell delays is automatically calculated, and the while load and capacitance at each and every point we need to calculate, right? These things will be used by spef format. Spef, in spef file we used to have all these things. Spef file, there was different types of spef, dspef uh, and rspef. There are different formats. So and after that we used to have power analysis. In power analysis we used to do whether the static power, dynamic power analysis. After that, in static power we used to have the, whenever we used to give the constant input to my device, so this static power, the power consumed by my chip is the static power. Whenever dynamic power, if you had, right? So dynamic power we used to have, no? So in the dynamic power we used to check for the if my device is switching from logic 1 to 0, or 0 to 1, or 1 to 0, then the power we used to say as dynamic power. The dynamic power is nothing but the power consumed during the switching activity happened. So that is power. And the short circuit power, the short circuit power is the flow of current from the VDD to ground. This may lead to leakage and damage my device. This need to be avoided in my design. IR drop analysis. IR drop analysis is nothing but if let us take this. This is my chip. This is my chip. Inside that there is one of my standard cell. So if I am giving VDD here, so if I am doing routing here to here, so obviously there will be a resistance drop of this much. Resistance drop will be happen due to the resistance of the wire. So we need to reduce that to, we need to do some techniques. We used to have power grid technique or mesh type of thing. So mesh, how it look like was, if it is, if my standard cell is here, so we create a mesh type of like this, horizontal mesh and the vertical mesh. So why we are doing this mesh type of things was, inside here my standard cell is going to place inside one mesh. In one mesh my standard cells like this, like inside. So each part of this each cell is getting the uniform power. That is what we are doing. So it is easy that there won't be any IR drop like this if it is doing for each and every pin. If you are taking, if one cell is here, one cell is here, that is difficult, right? More number of routing resources. If I am creating a grid type of thing or mesh type of thing, so that is easy for doing analysis, like drop analysis. Like it is the uniform power I am getting. So this is what, how much the voltage drop. If I am giving 5 volts here, obviously there will be some 4.9 or any 4.95. If it is like from here, if I am giving 5 volts, it definitely it will be uh, more or less for 4.8 to 4.5, 4.8, like that it will be. So we need to reduce. So if I am giving, I am using multiple VDDs here. One VDD stripes, we used to say as the horizontal stripes and the vertical stripes. That is what. After that airdrop analysis, we used to do the tape out. After this video we are going to discuss about the inputs of each and every stage. So we are going to discuss in detailed manner. So if you need more number of videos and contents on PD related stuff, so we can discuss. And if you had any doubts, you can comment here. And please do subscribe to my channel. And please do like and share, comment. That is the end of the topic. Thank you.